Hi, my name is Monique Banks and I'm in second year architecture level 4. This is my first semester of architecture. I recently transferred from building design and I'm doing this as a 12 credit point elective, the sense of sustainability, and I've opted to do the sense of relativity with Daniel Prohasky. My initial design idea was to create a paneling system that would be able to adapt to the sun's movement using sensors. This was then going to be used to be able to control thermal phenomena within the pavilion using reflection, refraction, and deflection. The pavilion design was shaped to facilitate two sectors in which two contrasting types of thermal phenomena could be experienced. The two torus shapes allow entrance from both ends of the pavilion for the public and allowed optimal radial thermodynamics to be deflected. One sector will focus on the thermal phenomena of coolth and the other warmth, that will be controlled through a paneling system where light is deflected and reflected and dispersed into each particular sector within the pavilion. Each panel would have to be configured to a sensor which could detect the sun's movement and deflect its rays of light so that the angle of reflection is perpendicular to the angle of incidence. I began looking at the physiological effects of light and more closely at how colored light could affect humans. White light is actually made up of an array of colors. It is only through their wavelengths and angles of deviation that it can be seen through a prism. Color can influence physiological effects within somebody. However, it is debatable as to how much this is actually physiological or psychological due to one's affiliation with the color and how that can actually impact one's physiological state. By deflecting particular colors off a prism and focusing these colors, it is able to invoke particular temperatures, atmospheres, and environments that can be controlled through thermal phenomena from the sun into sectors of the pavilion. Much like physiological aspects of light and color, psychologically, light can invoke a series of temperatures as well. Temperatures are often perceived through the affiliations one draws from particular colors. Obvious examples being the hues of cool colors, such as blue, and the affiliations of wind, sky, and what stimulates a sensation of psychologically of a cool environment. This can also be seen in the hues of warmer colors, such as red, and the affiliation of sun and fire, invoking the ideology of a warm environment psychologically. To implement this approach, the specific angle of the sun had to be calculated from a specific location and time, where the panel could rotate perpendicular to its movement. The site being located at the Barcelona beach with a latitude of 41.38 and a longitude of 2.19 was used for the input in Grasshopper. The site being located here to gain pedestrian access from both the public of the beach and the public of the main street. Similarly, a drastic temperature change would be evident across the shores of the water and facing inland, which would make the use of a warmer sector appropriate across the watershore. The sector required to be lit was mapped through a curved reflection trajectory which would alter to be perpendicular to the panel it was reflected from, changing alongside the movement of the sun from sunset to sunrise. The next step was to test the intensity of light and how much could be reflected at different distances. A curved concave area with reflective material was placed underneath the sensors to better capture light onto the sensor, to measure light under different distances and intensities. All 6 sensors were tested against a light source of 4 different intervals, 1 cm, 5, 10, and 15. With the assistance of Daniel Prohasky and Arduino, I was able to configure some results which showed that as the intensity of light increased, due to the distance of the sensor becoming closer to the light source, the resistance decreased. This simulation calculated the intensity required to be able to reflect these rays of light and how much the panels would be able to rotate to reflect these rays at the correct intensity. To test the angle of the panels needed to be rotated in order for light to be reflected in specific areas in the pavilion. The concept of color, light, and reflection were tested with Yin Yang He's pavilion, which we prototyped together. Mirrors were placed on the corners where it would be perpendicular from the light source, being the sun in reality. These mirrors were then made adaptable to simulate the rotation of panels that would adapt to always be perpendicular to reflect a particular color in the pavilion. The primary colors that compose the dispersion of white light were used and overlapped at the intersection where different hues are produced between primary colors. To replicate the reflection of color through a prism, Cellophane and bamboo were used to simulate the reflections of light that were dispersed from a light source, when directed at different angles from the panels, being the mirrors. Several simulations showed that as the sun rotated around the pavilion, or in this case the light source, being the torch, the reflection and refraction dispersed through the prism will disperse an arrangement of different colors depending on the angle of the light source and where it hits the prism, as well as the wavelength of each of the colors. The final exhibition shows the display of reflections from the light being dispersed through the prototype prism onto the white surface and the variation of colors. This page explains the physiological changes that occurred throughout the endeavor of the Casa Butler, which was the skis we were given, which now Daniel will be continuing on for further research. The final pages try to give a sense of atmospheric play that could be experienced with thermal phenomena within the pavilion, through the following renders. I hope you enjoyed my presentation and thank you for listening. Gracias.